This video concentrates on the conversions that we're going to use within the rendering engine as part of the distributed computing game engine. The first question should really be, why are we creating a scripting engine? Why not just use a fixed format level file? Well, the idea of this system is to make it as flexible as possible so we could use it for more than just games. Distributed applications would then be able to send information to the rendering engine across the internet and actually render things locally. So it makes constructing the rendered image possible in a flexible way. Like HTML, we want to try and make the script as human readable as possible. So we're going to use English commands which can then be converted into a computer format for the computer to use easier. By keeping this information in a text format, it makes it more future-proof than using a binary format where you have to then describe how the file actually works. It also means that in the future we can improve the rendering engine, and any old scripts will still actually see an improvement in how they work. So here we have a very simple script example. We're going to start by clearing our environment, so we're going to blank it out, and it's an infinitely sized environment, but we're going to start back at position 0, 0. We're then going to add a new graphic to our graphics list. We're going to call it BGND tile, as in a background tile, and it's a file locally on my computer, so I'm going to access it from my C images folder, and it's called tile.jpg. So now the graphic is now stored in memory and we can start using it. I'm going to add a camera, which is how we view this environment, into my world, into my environment. I'm going to call it main cam. I'm going to set its top left corner to be on the 0, 0 point of the environment. I'm going to make its resolution 640 pixels by 480 pixels, and I can choose between a normal camera, a left eye camera and a right eye camera, so I can use it with a 3D projector. Finally, I'm going to tell the computer to set the environment up, so it's going to tile the background with background tile, and it's going to use black 0, 0, 0 as its background colour. So if there's a point in the background where there isn't a background image, because you can set it without a background image if you wish, it would show up as black instead. I can choose to either scale the background tile to match the size of my camera, so that would mean however big my tile.jpg was, it would be changed to 640 by 480. In this case, I'm saying no to scaling, and that means it will appear on the screen at whatever size the tile is currently set to by the graphic itself. The first conversion we're going to need to do is convert from the English commands that we've got into machine code. For this I'm going to use a hash table, which is basically like a lookup table where you have a key and that matches a value pair. Okay, so like a dictionary, if I search a hash table called commands for a key, I can find out what that value is. I'm going to set our machine codes to being the key in this hash table and make the values a full description of what the command should do in English. So let's see an example of that. My computer code is going to be LH. All my computer codes are actually 2 characters in length, and they're designed to be a bit like assembler. So it's not exactly machine code, but it's harder to understand than the human readable code. Inside my value I'm going to write the command list command history with no parameters. And then I've got this English description. This lists all the commands that have been applied to this session. As you apply the commands into the environment, it actually saves exactly what you've applied, so you could record it to a script file afterwards and turn that into a level file if you so wished. So how do we actually do this conversion from English to machine code? Well, we take the English command that's been entered, and we take away all the parameters, commas, brackets, etc. So we're left with just the beginning part of the command. We then turn that to being uppercase, because case sensitivity happens all the time when you're comparing strings with other strings. So we're going to set them both to being uppercase, both that and the value in the hash table to uppercase. We then go through the entire list of all our different commands, saying, does the beginning of that value in that hash table equal the command that someone's typed in? If it does equal, that'll bring a string index value of 0 into the system. If it reaches that, it's going to say, right, the key for that value is whatever the command is. If it doesn't find the command, it will just tell the user, command not found. So we've got our command list in a hash table, and by having it in just one place like this, we can use it for not just doing the translating between computer and human readable codes, we can also use it as an online help for the user using our engine. They can type LC, lookup command, bracket, and the name of the command they want to know about, and they can actually get it out of this table straight away. It also makes it really easy for us to create and use it as a reference for making the scripting engine with. So the first thing I've done is create a huge long table of all the different commands that I want to use in my environment. Now that's not the only type of conversion we're going to do. One of the other major conversions that I'm going to talk about now are tile maps. Now the background is going to normally be created from a series of tiles where you put down exactly what you want, like a tiler would do, and you say I want this tile, this tile, this tile, this tile, and you can construct the entire background of your level using that method. So what we do, we have a single graphic which stores all the different possible tiles, up to 256. Unlike my first version of my game engine, this will allow you to use multiple tile maps on one background so that you're not limited to just 256 different tiles in total. We're then going to use a coordinate system to work out which of the tiles on this picture of tiles we want to use. I've done it 16 by 16 so we can use hexadecimal numbers. So for example, the number A would actually be 11 because we're starting with a 0 index. So the first tile is 1, but actually it'd be 0, 0, and so on and so on. So F, although it's actually the hexadecimal number 15, it's actually the 16th tile along. We can then write out a string to describe the whole background image. But to take this string, we would actually need to convert it into some other format to use directly in the program. So what we're going to do is convert this hexadecimal string, which would be a huge long list of letters, into a 3D integer array, where you have the x and y location of every square that's going to be on the background image, and x, y, 0 stores the x location of the tile on the map, x, y, 1 stores the y location of the tile on the map. So these conversions are the most important ones we're going to have in our distributed programming language, in our rendering engine.